Let me discuss few more points on the architecture part, and after that we'll get on to the practical execution. Okay. Um, okay. So, what did you understand, like by seeing this architecture? What did I tell you last time?
It's like a cluster, one master, one
Uh-huh.
slave.
So,
Slave
which one is master here? Which one is slave here?
cluster manager is the
Driver
master. Yeah,
programs.
first two
Uh-huh.
will maybe
Okay. So
Driver
this one is
executors
the
are
programs.
master.
Yes.
Okay. And this one is nothing but your slave or
slave. Slave.
worker node. That is
What?
what I told you, right?
Yes.
Okay. What does it do actually? Let's say I'm just trying to execute my word count program actually. Slave or worker node.
Worker.
Work.
Parallelism.
Oh, okay. Huh. So let's say I'm just trying to execute actually. Okay. So I just wanted to make sure like you understand the architecture completely, because today's discussion is a little bit depending on this architecture. That is the reason I'm just repeating that. Okay. It won't take much time. Just I'll try to execute that. Okay. So let's say I have a text file, guys, actually. In a text file, I have like, let's say some content is there. The file size is actually 500 MB. 500 MB. The text file size is 500 MB. So I've asked my Spark to count the number of votes. I mean, how many times each word got repeated. That is my task actually. Consider that just a simple example. Okay. So I have a file. The file name is called file1.txt. That file1.txt, I've written a program actually, word count program, and I submitted to the driver program. So initially, what happened here? What happens here? What driver program does actually? So let's say we have 500 MB of data here. Okay. What it does actually? So directly it will take 500 MB of data and it will give it to each executor. 500 MB will be given to all the executors.
I
No,
think
it will
64
split
they will be distributed,
64
sir.
bit.
What is the
Distributed.
core concept of the Spark or Hadoop?
They'll take and they'll split into 64 and then they'll assign to each
Ah,
worker.
All 64
yes.
will
Okay. So divide and conquer, right? So instead of doing the work by one mission, so they'll try to divide that work by multiple slaves or worker nodes, and they do it parallelly so that it can be completed very quickly. See, I'm just trying to compare with the traditional approach here. Okay, so what happened initially, here? So this 500 MB of data logically will be divided into partitions. Okay, so Siva, what is the default logical partition size here? What is the default size? Okay, in Hadoop 1.0, Hadoop 1.0 only, the partition size was actually 64 MB. Okay, so after that, things got evolved, right? I told you in Spark, Hadoop 2.0 and 3.0, so it got changed to 128 MB actually.
Okay.
128 MB. Okay. Now in the latest versions, I think each partition size it is taking actually 256 MB in the latest
256.
versions. 256. Logical partition size, I'm telling. See, your Spark will not divide the data physically into partitions. Logically, it divides actually. You know what happens? Recently, I explored in real-time program actually. You know what happened here? If you have a text file like this, Spark will try to search for slash and character in this file. What is the slash and character?
Next
Like
line.
Backslash n is what? New line character, right?
next line.
So
Yes.
New
it will
line.
try to identify the slash and characters in this particular file. Okay, let's say 10,000 lines are there here. Okay, so consider it is okay. For now, you just consider. I'll tell you the exact in Spark 4.0 or Spark 3.0. What is the default partition size? I'll let you know like end of the class. So for now, you just consider each partition size is 128 MB. So if it is taking the default partition size as 128 MB, how many partitions it is going to create in the backend? Let's consider we have 10,000 lines here. Now tell me
4.
how many 128 blocks you'll get here.
4 partitions.
4 partitions, right? So 128, 128, 120 you'll get. So something like 3, what you'll get? 128, 128, and how much you'll get here?
I think another 128, 512 is
384 you'll get something like this.
Yes.
Okay. So remaining will be distributed to another partition, actually, remaining memory. 500 minus 384, whatever the number you get, that number will be that will become a 4th partition. Okay. So here the driver program will divide that data into logical partitions, guys. So let's consider here P1, P2, P3 like this. 1 second. So this is P1, this is P2, and this is P3, and one more partition. Let's consider this is P4. So first point is what it does in the backend is it will simply divide that data into logical partitions, not physically, logical partitions. It will simply find out that slash and character. Let's say if you have 10,000 lines or 9,000 lines, 2,500 into one partition, 2,500 lines into another partition, 2,500 into another partition, remaining lines into another partition. Okay, so based on the slash and character, it will try to divide that. Almost it will try to distribute the data equally, guys. Almost it will try. It tries maximum to create, at most it will try to create equal partitions here. Last partition anyway, you will not get the same size of the other partitions because the remaining memory will be spilled out to the last partition. Every time you will not get the 128 multiplication memory, right? So that is the reason large partition always is less than the other partitions. Size I'm talking here. Okay. Now, so what it does is this driver program, backend it is going to create a stages case. That stages concept I'll talk little later. That stages again will be divided into task actually. Don't ask me like what is stage here. Okay, I'll talk about that one little later. Okay. So for now, each partition backend it is considering as one task. Now, task 1, task 2, task 3, and task 4, it is trying to create like this. Okay, now cluster, okay, now the driver program will go and ask cluster manager, hey, cluster manager, now I have 4 tasks total with me. Okay, user has submitted one program actually, and I've created in the backend 4 tasks. Now I need resources from your from the worker nodes. Remember that, guys. In real time, even you're trying to interact with the cluster actually, you will not have access to the worker nodes. You will never have access to the worker nodes. Always you'll be talking to the master node only. Always you'll be talking to the driver node only, I can say. Even in the Hadoop, even in the Spark as well. Okay, anyway, we don't need to deep dive into cluster actually at this point of time. Okay, we'll understand it a bit later. Now, what it does is cluster manager, it will go and check actually, which executors are free at that point of time. So this executor might be executing the program. This might be free at that time. This might be executing this at that point of time. So it will go and request all these executors, hey, who are all free? Just report to me. Okay. Okay. So it will go and ask all the executors, hey, who are all free? Just report to me so that I'll assign some tasks to you. Okay. So just a master slave architecture case. How the project manager is giving work to the team, to the team, right? In the same way it works here. Even project team also works based on the master slave architecture, right? Okay. So in the same way here also, so this will go and talk to each and every executor. Then it will try to get the free resources here, and it will hand over that one to the driver program. Okay, now the driver program will allocate these tasks to the respective executors who are all free. See, currently I'm showing here only 3 executors, but in real time you may have 10 executors, 20 executors, 30 executors, 64 executors. You may have anything depending on your cluster configuration, I can say. Depending on your cluster configuration. Okay, so there is no guarantee that T1 will be allocated to this executor, or T1 will be allocated to this executor. So that depends on the availability of the resources, I can say. That depends on the availability of the executor. See, at a high
Yes,
level,
no.
actually, I'm saying each worker is an executor. But I told you, if I deep dive little bit on this architecture, I've told you already, in a worker node, you may have multiple executors. Multiple executors. What is this what does this executors meaning is? Let's say if my worker node is having 64 GB of RAM and 16 cores configuration. That is the configuration of each worker node. Okay. So, okay. Now let me try to write down here. 64 GB of RAM. I'm going to discuss everything with respect to RAM and cores only. I'm going to talk the configuration only in terms of RAM and cores here. Okay. So let's consider 16 core system is this worker is actually 16 core system. You guys know what is cores, right? Okay. So my system is actually, let me show you how many cores it has. Task manager. I think here, if I go to performance, see how many cores are there here? 4 core system. That means it's a quad core. Quad means 4, right? It's a quad core system. But logically, how many processors are there? 8 processors are there. Okay, so like that, the worker node might be having like 64. Uh, i- let's consider it is having 64 GB and 16 cores. Now, what I will do is I'll try to divide this into equal parts. When I say equal part, let's say I wanted to divide this into 4 parts actually. 4 parts means if I divide this one into 4, this one into 4, how many? What is that configuration you'll get here for each
16
execute?
GB.
4 GB from this one, 4 cores from this one, correct? 4 GB RAM, 4 cores together, we call it as a executor. Each executor can perform one task. Getting my point here? Clear with the architecture here? Okay. At least okay. Okay. You'll understand it. Don't worry. Okay. So what I'm trying to say is, I'm just trying to divide it into 4 parts here. When I say 4 parts, I'll just try to divide this RAM into 4 parts and cores into 4 parts. So 4 cores and 4 GB of RAM together, I call it as an executor. So one worker node can contain multiple executors. Multiple executor, or it can see one worker node can have 64 GB, 16 cores can act as a single executor as well. That depends on the configuration that you set. One worker node can act as one executor as well. But usually we'll be having multiple executors in a worker node. Okay. Now one executor can perform or can execute one task actually. Okay, like that one worker node parallelly it can execute 4 tasks. That is the reason I'm telling you, based on the configuration, your all 4 tasks can be assigned to one worker node or can be equally distributed to different worker nodes. Your task 1 can be executed by this executor, can be executed by this executor, can be executed by this executor. That depends on the availability of at that particular point of time. Who is going to decide that one? Your scheduler or your resource manager decides that actually. Resource manager decides that. Resource manager is nothing but a cluster manager. Resource manager. Someone who is managing the resources. When I say resources, RAM and cores. That's it. When I say core, threads, parallel threads. Getting my point?
Yeah, Shiva, here same task can be distributed to multiple executed tasks, right? Otherwise,
No,
if
no.
one
One task will be allocated to only one executor.
one executor only.
Uh,
Okay. If
so
any this one executor node fails, then it will be difficult.
I'll come to that point. Now, let's say in between, while executing this task one, actually, something got failed here. There was some hardware failure, or there could be like some software failure, or there could be some network failure. There could be something else. Okay, in that case, immediately resource manager interacts with this one. See, immediately this worker node will go and interact with the like resource manager. Hey, I'm not able to execute the task, or something happened to me. Then automatically the resource manager will deallocate the task from this one. It reallocates that one to the other worker nodes or other executor, I can say. See, that interaction will happen internally. You don't need to worry about that one. See, what if in a project actually, if one person is not able to do the project work, then what manager will do? What manager will do? He will
Assign to other
obviously allocate
person.
that or
Just
assign
leave
that
other
work to
person.
the other project teammate, right?
Yeah.
Same way here also. Practically, it is as simple as that. That's it. Clear with that?
Yes, sure.
Okay, so this is the architecture, guys. This is the backend execution model, I can say. Even if somebody asks you, hey, how it is going to work actually in the backend, you need to explain all these things. Okay, and one more thing actually, how it is interacting with the worker nodes, how it is interacting with the driver node. So we like I'm going to discuss, I'm planning to discuss that one with the yarn architecture. It is a separate discussion, guys, actually. So that will take almost 40 minutes of time for me to explain that, to make you understand about that one. So I'll take separate class for that one. So I'll tell you how the interaction will happen between the systems here, between the executor and the driver.
Mhm.
Okay. So that language I'll try to explain here. Language means like how they're interacting. How do they speak? Okay.
Okay.
How the
Now, one
communication will happen between these nodes. Mm.
one doubt, sure. You
Mm.
said 400 MB file.
Mm-hmm.
It took into four partitions and
Mm-hmm.
then four tasks, right?
Mm-hmm.
Is it mandatory to go? It's based on available resources only. It will split, right? If there is only two resources are available.
No, no, no. The task division is not based on the number of executors availability. That is by default. I told you the file size that you're setting.
Okay.
Okay, let me tell you the default file size in Spark. One second, let me erase all these things. Just a second. I'll just take the perplexity help here. Okay. What is the default partition size, right?
Yeah.
Partition size in Spark 3.0 and Spark 4.0. I just wanted to see the differences here. Okay, I mean partition difference. See here, 128 MB, Spark 3.0. Okay, see, and one more thing, 128 MB only. Okay, so 4.0 also like 128 MB only. Okay. And one more thing, by default, if you don't mention anything, by default, it creates a 200 party. This is the default number. This is one of the interview question actually. This is one of the interview question. By default, it creates 200 partition. I mean, if the size is, let's say, 1 TB or 2 TB or 10 TB like that. If it is a small file, of course, it does. There is no like that doesn't make sense to create a 200 partitions here.
Okay.
Got my point?
If okay, the size limit is not fitting within 200, what will happen? It will leave the task,
Yeah,
the consume.
yeah,
Again, it will
correct, correct,
start.
correct. No, that is what I was telling you. So it will try to create one task is nothing, one partition is nothing, but 128 MB blocks it will
Yes.
create. I mean, let's say if you try to divide that 10 TB divided with the 128 MB, if you're getting more than 200,
Yes.
I'm telling you by default it creates 200 MB here.
Okay. So automatically that 128 will change into 200.
Yeah, correct. No, 200 is not the size. This is the number of
No, no, no.
partitions, I can
No.
say.
I mean to say, if it is
Okay,
okay,
okay, okay. I got your point.
it exceeds 200. In the
Mm,
first attempt itself, it got something count by 250 or 260.
uh,
What
uh,
will
uh.
happen to that 260, remaining 60?
I'll let you know that about that one. I'll let you know definitely. I got your question. Okay.
Usually, it's a worst scenario. No,
Uh, 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 uh.
file won't be that much big.
Mm-hmm. Even if that is the case, we need to understand about that. part. Okay. Hmm. I'll let you know definitely. It's a good
Okay,
point.
sure.
Okay.
Now, okay, as you
Hmm.
said, the
Hmm.
file will split into 128 MB.
Hmm.
So that 128 MB chunk of file will go to the any worker node.
Oh, any worker node, correct.
So that worker node based upon the inside task, it will
Hmm.
allocate, which is
Yes,
free.
correct.
I mean,
Hmm.
okay.
Free or busy, based on that one, it will allocate. If it is free, it will resource manager will go and allocate to that
Okay.
executor.
Yeah, Shiva, one
Hmm.
question like that master node contains like each executor and that respective worker nodes information, right?
Hmm.
So to know the availability of which task
Yes,
it will.
yes. Every worker node information must and should be available. That metadata should be available with the resource manager and the this guy, master node.
Master node.
Definitely that will be available. That it maintains that metadata definitely in the backend.
Internet, okay.
Who is doing what? See, even in the project also, who is doing what task? Manager maintains it or not in an Excel sheet. Every day he tracks it or not. It is as
Yeah.
simple as that.
Mm.
So if project manager is not maintaining that metadata, then how does he come to know what is the status of that project, whether it is in red, amber, or green? Like how does he come to know that? Who is doing what? If he doesn't know, then doesn't make sense, right? So in the same way here also, that metadata it maintains definitely.
So it will take care automatically. So we
Ah,
don't have to configure anything
you
to
don't need to
make it
configure anything actually.
configure. Okay.
Ah. See, previously in 2017-18 time, we used to have actually standalone Spark or like on-premise Spark clusters we used to maintain. We used to work with those things actually. There, everything we used to maintain with like I can say configurations. Okay, nowadays everything is cloud, right? You don't need to maintain anything from your end. It's very easy to handle with these clusters nowadays. Okay. Anyway, we'll discuss that one. Yeah, so that is what I wanted to tell you. Okay. So one more thing, guys. I told you already. Why are we discussing Siva? Why are you discussing only PySpark? Why not Scala Spark? Uh, some people might be having that question. Okay. I'll tell you the practical scenario here. Initially, when Spark came into the market, actually, most of the companies or most of the projects actually they started like using the Scala language. They used to write all their programs in a Scala language. I told you already, Spark is completely built on top of Scala language. Scala language. We used to even I worked with the Scala in one of the previous company, I can say. Okay. So completely built on top of Scala language. It's a Scala framework. Spark is just a Scala framework, I can say. It's a powerful execution engine. Okay. So Scala, and we can also use Python here. Okay. But Siva, it is actually built on top of Scala, right? Like, what is the significance of this Python here? See, Scala or Python is just an interface for you guys, but backend execution will happen through that Scala language only. Again, the Scala is built on top of Java language only. Just a wrapper on top of Scala is just a wrapper classes of the Java objects, I can say. Okay, so Python or Scala is just a interface for you. You're going to interact with the Spark with this Python or Scala programs. That's it. Okay, so when we used to use the Scala language as a programming language to write the commands or this one, right, programs, then what we need to do, here. So once we write the Scala program, we need to build actually jar file on top of it. Jar file. Okay, so for this one, for generating this one, we need to use some build tools like Maven SBT build tools we used to use. Ultimately, what I'm trying to say is we used to generate class files actually. So generating these jar files or building that class files is very tedious task actually. Very tedious task. That is an extra step actually to do that activity. So instead of doing that, with the help of Python, actually, what we can do, whatever the code that you wanted to write, simply write it in a .py file and try to submit that program to the Spark cluster. That's it. To the Spark cluster, you can directly, let's say, sample.py. You write whatever the program you wanted to write. Simply save it in a .py file and submit that one to the Spark cluster. It will simply execute that. But in this case, actually, you need to generate the jar file. That jar file, that build file, you need to submit it to the this one Spark cluster. That is an extra step actually we need to follow. That is again a tedious task, I can say. We used to get a lot of issues while generating this build. You have to be very careful while generating all these things. Now, it made very simple in Python. That is one reason why Python has become very popular. PySpark has become very popular with Spark combination. Okay, so that is what I'm trying to tell here. No need to compile, manage dependencies extra. In Scala, right, we need to manage the dependencies as well. So everything we need to download from the Maven repository, and we need to maintain that PAM file. Something is there in the backend. I forgot that file extension. Backend we used to maintain that dependency file actually. I forgot that extension. PAM file or something is there. We used to create that actually for dependencies. Okay, I worked on long back on this one. I forgot that extension. I'll let you know tomorrow that one. Okay, so we used to manage the dependencies. We have to build that jar file. We have to build that class file, and we have to manage all these things. Now in PySpark, we don't need to manage all these things. That is one beauty with the PySpark. Okay, so 80% of the projects they used to use actually Scala as their programming language as choice, I can say. Okay, 20% of the company they used to use actually PySpark for their in their projects. At that time, 2017-18 time actually, when you write a code in PySpark, the performance was a little slow when compared to the Scala programs because the compatibility was not that good at point. I mean, compatibility was okay, but back end some performance issues were there. That was also one of the reason why Scala, many people are using Scala, and very less people are using Python at that point of time. Later, what happened? That performance issues and all the things actually sorted out, and now the things got changed. Now the ratio got reversed here. Okay, so most of the companies are using PySpark here. Like very less companies are using Scala as their programming language for Spark implementation. See, I'm just giving a rough values here. Don't think that okay. So if you inquire like 10 companies, let's say 5 companies are using Scala, 5 companies are using Python. So you gave the wrong information here. 50% of the companies are using Scala, and 50% companies are using the Python, and you're lying here. No, I'm telling you rough percentage here. Most of the companies, as far as I know, most of the companies are using PySpark only for their implementations. Okay, compared to Scala, Python is very, very, very easy, guys. Very easy. Scala, you have to learn, understand too many things actually, because it is derived from Java, right? Actually, too many concepts are there in the Scala. Okay, so less coding overhead. I can say it's very simple. You might already know Python. Of course, since it is very simple to understand, easy to learn, the Python is preferable language, I can say here. Okay, Python has huge community. If you get an issue when you write some PySpark program, something, so you have your community, right? I mean, community in the sense like if you get some issue, then backend they'll try to give that solutions, right? So that community, it has huge community. You'll get solution definitely in one of the threads actually, and it has powerful libraries. You can manage hell lot of things in Python actually. Lakhs of libraries are there in Python. This is also one more reason why PySpark has become very popular. Okay, so and one more thing is we can focus on these Spark concepts, not like you don't need to learn a special language here to write to manage with the Spark. Just simply learn Python, and that is enough to manage your PySpark. That's it. Okay, so this is the reason actually I was telling you I was preferring to teach actually PySpark, not Scala Spark. But most of the commands are similar, guys. Scala commands and Python commands both are same one. Databricks supports Scala, Databricks supports PySpark as well. Scala Spark and PySpark as well, both. Databricks supports R and Java as well. Mostly we write with PySpark only, guys. Mostly 90% of the cases.
Okay, sure.
Okay. And of course, I told you Scala is probably a more popular choice with the Spark. I told you already because it is built backend with the Scala language, right? Interaction is very easy and execution is also very easy for that tool. That is the reason why I was telling you. And Spark is built in Scala, right? Built in on Scala, right? So coding in Scala is a native to the Spark. It is a native to the Spark. And any new features comes in Spark, right? It comes libraries tend to be in Scala first. They'll release that into Scala first, actually. That features, new features. Okay, anyway, I don't want to like discuss too many things here. I was just trying to focus here. PySpark is the more like mostly used language in the industry. That's what I wanted to tell you here. Okay.
Okay.
Now we need to understand. Uh, this is what I was telling you guys. Once you submit the data to the Spark, it tries to divide that into partitions, logical partitions, not physical partitions, I can say. Okay, so first partition, second partition, third partition, fourth one. Almost it will try to divide that into equal size actually in all the partitions. Mostly it will try. But there is no, I'm not giving any guarantee that every time it is going to create equal partition. No, sometimes you will get into data skew issues as well. The data skewness is also one of the performance oriented concept in Spark. Okay, so data skewness, I mean, at high level, I'm just trying to tell you, one partition may have huge volume of data. One partition may have very less volume of data. You may have the differences also sometimes. Okay. So that we call it as a data skewness. We have different techniques are there to avoid that one. Recently, they introduced actually AQE, that is adaptive query enable. Based on that, it will automatically internally handle that. You don't need to take care of that actually. Okay, yeah, fine with that. Um, huh. So this is what I was telling you. So guys, Spark backend actually it creates the partitions. Let me tell you about that one. Uh, Spark backend maintains actually RDDs. Even nowadays, even now also, Spark actually backend creates RDDs only. The backend base unit or base what I can say measure is actually RDDs. Even if you execute data frames, I'll talk about the data frames. Don't worry about that one. Even if you execute everything in data frames, backend it is going to convert the data frames into RDDs. So what is the what is the full form of RDD? Resilient distributed data set. Okay, so each data set is logically partitions and distributed across the nodes over the cluster. They are just partitions to enhance the processing, not divided internally. And this arrangement of partitions provides the parallelism. The more partition, the more parallelism you'll get. And RDD stores the data in a read-only mode. I told you already, read-only mode. Nobody can change the data once it is logically divides that. Nobody can modify the data. RDDs are immutable, guys. Somewhere I mentioned, yeah, this is the point. RDDs are immutable, actually. You cannot change that. Okay, performing operations on existing RDD create. Okay, I'll talk about this one also. Okay, so now for this whole week, I'm going to discuss about the RDD's concepts only. Nowadays, we are not using RDD's concept in real time. But still, Shiva, why are you discussing? Why are you wasting our time? Because some basic core concepts are actually like we need to understand only with the RDDs, not with the data frames. Some core concepts are there that we need to understand only with the RDDs. That is the reason I'm discussing. I don't have like any other thing like wasting your time and doing the things here. Okay. So Spark has all these features, guys, actually. In-memory computation. I told you everything, the execution happen in RAM only, not in the not through the this. Okay. So I'll talk about this lazy evaluation also in some time. Fault tolerance is nothing but even something happens in the cluster, even something happens in the during the execution or after the execution, or if something happens to the worker node or something happens to the executor, it automatically recovers the data from the source, from the base RDD, I can say, and it continues the execution. That we call it as a fault tolerance. So persistence is also one of the feature, and it is of course distributed. I told you already. Parallel processing, I told you already. The more the number of partitions it is dividing, the more the number of cores or executors you have, the more the parallelism you will get. Okay. So these are all the features of the Spark. Okay. Now we are good with that one. Now let's get on to the actual practical part in Spark. Okay. Before I go ahead and do that one, I wanted to execute these commands actually. Okay. Uh, mm. So if at all, if you want to execute any Spark program, these lines are mandatory case. Only in the local Spark, I can say, not in the Databricks Spark. I'll talk about that one. Don't worry. Okay. So what are these commands actually that you need to understand first? Okay. So first, I'm importing the necessary libraries here. What libraries are these? Find Spark is. Uh, do you remember? Like yesterday, we were trying to execute one command conda-install like find Spark. We were installing that library, right? So that we are trying to import here. Whatever the library we installed yesterday, that we are trying to import here. I'll tell you the use of this one. So from PySpark.sql, Spark session also I'm trying to import. Spark session is just a class from this PySpark library. And SQL, that too, I'm trying to take SQL related Spark session. Okay, I'll talk about this one also in depth once we get into the actual implementation, not now. Okay, what is Spark session, what is Spark context, and all those things I'll try to talk. Okay, now uh, what I'm doing here actually, this Jupyter notebook is a Python based IDE, right? Correct? Jupyter notebook is a Python based IDE, right? Or not? I mean, it can execute the Python programs or not? It's
Yes.
correct. Okay.
Yes.
But we are also executing the Spark commands through it. How come your Python UI is talking to Spark? It has to talk, right? Your Python has to go and interact with the Spark cluster, right? That means
Libraries.
through libraries only. Okay. I mean, let me continue this. Okay. What happens, if you want to write actually, if you want to execute select star from some table or select like count of star, select some of salary from the employee table group by something, group by department. If you want to write some SQL commands in SQL Server, what do you do? I think I have SSMS here. Let me open this one. What do you do generally? What do you do? So backend some database is there. Directly with the help of this UI. Okay, let's say this is my like database in the backend. From this UI, directly can you go and execute that? No, right? What we need to do? We need to create a session right here. How do you create a session here? Just click on new query, right? That's what you do, right? This is my local SQL Server actually.
Yeah.
What do you do here? You will create a right click here, you will just click on that new query, so that what it does,
Establish a session.
it establishes the connection between this UI and the database. That's where when you write some query here, select star from EMP, that's where when you write something, actually it can go and get the data from the database in the backend. Consider your Spark is also behaving in the same way. Backend somewhere we have the Spark actually. Now Python is actually trying to interact with that Spark. Now it has to initiate that Spark in the backend. It has to create a session in the backend. For that, to initialize that one, for in order to find that Spark path, in order to initialize that Spark in the backend, we need to write this command: find spark dot init. Init is nothing but a method here on top of this find spark object. So it is going to initialize the Spark. How it is going to do, find spark will go and actually take the from the environmental variables. It will identify the spark home that yesterday we have defined, right? From there, it will try to get that spark path and it will try to create a session. Now, indirectly, this command is creating a session between this UI and the Spark cluster. That's it. Got my point?
Yeah.
Okay. Everything is SQL, guys. Just compare with the SQL here. That's it. If you know SQL, if you're good at SQL, SpicePark is jujube, I can say. Very easy. There you will interact with SQL language. Here you will interact. Here also you can write SQL commands. Happily you can write SQL commands. But in programmatic way, you write it. That's it. Okay. Now. So after that, what we are doing, we have to create actually now the interaction it will try to create. So backend it is, we are just establishing a session here. For that, we are just using Spark equal to Spark session dot. Spark session is just a class in the backend, the PySpark. So we have an attribute called builder. On top of that one, we are telling to Python, we are telling to Spark, hey, we have to tell to Spark actually who is master, who is slave, and how many cores are there, how many cores you wanted to use, that we have to mention here in the configuration actually. For that, I'm telling to, hey, in the master actually, try to use as many nodes as possible. Local of star means if you use only 4 here, it will try to use only 4 cores in the backend. If you use 6 here, it will try to use only 6. If you use star here, it will try to use how many, if 10 cores are available in your system, it will try to make use of 10 cores. So you can restrict that actually. So when I say star, it will try to use maximum number of cores. Okay, from the master, it will try to use all the cores. Dot config of who is the master here? Who is the driver? Driver is actually, see, Spark actually works on the cluster. See, ultimately, our Hadoop or Spark concept is to, if you have big data and you have to divide that into multiple partitions, that multiple partition has to be executed parallelly so that the execution will happen quickly. In it, when you compare with the traditional way, that is our concept actually, core concept actually here. So since I don't have, I have installed Spark only in my local system here, I don't have cluster concept here. My system will act as a master. My system itself will act as a slave also. My system is acting as a master and as well as slave as well. So I'm telling, hey, local host, you try to use it as a driver. From that, you try to use as many cores as possible. Okay. And after that, app name. So you're executing this entire program. Okay. Let's say you are executing this program. Your friend, your colleague also executing one program. Okay. And one of other colleague is also executing your program. One more program. When you submit this, and ultimately, what do we know? Once you write the program, we submit this one to the Spark cluster. We have to submit this program to the Spark cluster. When you submit that program to the Spark cluster, you have to track that one, right? Whether it is executing or not, how many partitions it has divided, how long it is executing, any performance bottlenecks are there. How do you track that one actually? Based on some name, right? That is what the app name is, nothing but application name. Your program name, I can say. Your entire program name, I can say. That is what I'm trying to take here. PySpark RDD. You can give any name here. You can write your own name also, no problem at all. I'm just giving some meaningful name here. So since we are trying to understand the RDDs here, I have just given here PySpark RDD. Okay. And the last dot getter create. You know what happened with the getter create method? If the Spark session is already available, okay, it will try to get it. If the Spark session
Bro,
is not available, it will try to create it.
ఇసురుతున్నాడు కదా సార్ ఈరోజు.
Okay. If the Spark session is available, it will try to get it. If the Spark session is not available, it will try to create it. That's it. That is the meaning of getter create. Okay. On top of that one, you're creating a Spark session here. On top of that one, you're just creating a Spark context. I'll talk about that one Spark context also in one of the class, definitely. For now, you just try to understand SC is a Spark context. We are just creating a object here. SC is an object because all RDDs actually, in order to work with RDDs, Spark context is required. Definitely required. RDDs are actually part of the Spark context. That is the reason why from the Spark object, actually, I'm just trying to take Spark context. I'm just creating an object here. Okay. And Spark, I'm just trying to display here so that it is creating like this. Okay. Let me execute it once again. Okay. Now see, it is executing. So if it is executing, you will get this symbol, guys. Okay. Remember always. Now it is executing. It is creating a session in the backend. Since the Spark session is not available, it is trying to create a new one. The one that I've created yesterday would have expired by this time. Still it is executing. Yeah.
Need kernel restart.
Not required. Let's see. Let's wait for few more seconds. After that, we'll try to restart that.
Shiva, we can say this Jupyter notebook as a Python UA.
No, Python, yeah, correct. It's a Python IDE, right? You're
Python
interacting.
like SQL Manager Studio, like
Yeah,
how,
that's it. That's it.
like
I'm just restarting the kernel here. Now kernel is ready. Now I'm executing it. Now it is executing. Now let's see whether it is going to give the quick response or not. We have to wait, no other way. Just a second. I think, did I close that? I think Anaconda prompt, I closed it. That is the reason why it is taking more time. Let's see, let's wait. Or I'll do one thing. Jupyter notebook.
Shiva, every time we need to go to Anaconda prompt and Jupyter notebook.
We need to open the
There only,
Jupyter notebook
or
from there.
there.
But in Databricks, you don't need to. But in Databricks, by default, you'll get the COI only.
Yeah,
Okay, only in the local Spark, you need to do that. Okay, anyway, I'm just closing this one. Okay, I'm just trying to do this. Now it is executing. Let's see. I don't know why it is taking this much of time. Usually it won't take. Hmm. Okay, let's discuss meanwhile the concepts actually. I don't want to or anyway it is 22, 25. I can discuss tomorrow also. Okay, let me go over here. Meanwhile, let me discuss this one. Okay, so let's understand the RDD, how to create an RDD, how we can interact, how we can do the commands here. That's what I'm going to explain. So there are three different ways are there to create an RDD, guys, in PySpark or in the Scala Spark. In Spark, I can say, not specific to PySpark. In Spark, if at all, if you want to create an RDD, there are three different ways are there. First way is parallelizing the collection. That means parallelized method we have to use actually. And second one is actually by reading the text file from the external datasets. When I say external dataset, Spark can read the data from LFS, that means local file system. That's what we are going to do tomorrow. And Spark can read the data from HDFS as well. Spark can read the data from HBase as well. Spark can read the data from the Cassandra as well. Spark can read the data from the GFS as well, Google File System. Spark can read the data from Blob as well. Okay, so by reading the text file, we can create an RDD, or by creating another RDD also, we can create a creating an RDD from the existing RDD also creates an RDD in the backend. Okay, just try to understand this one. We'll practically see all these things tomorrow anyway. Okay. So in order to create an RDD in PySpark, right? This is the command actually. So what's RDD equal to SC dot? I told you already, all these RDDs are there in the Spark context. That is the reason why for every RDD, all these methods actually, you have to use SC dot parallelize of. Parallelize is nothing but you try to create a partition in the backend. That's what it is going to create an RDD in the backend. I can say it's a RDD command. So parallelize will take iterator as an object, I can say, as an input, I can say. So I'm just giving fish, cats, dogs here. This is the command to create an RDD in PySpark. So if at all, if you want to do the same thing in Scala, you have to do like val, words RDD. Val you have to use for always for the variables actually in Scala. That is the difference between the PySpark and the Scala Spark. So rest of the commands are same here, but we need to use actually, we need to mention like this, a list of this one. Okay, in Scala, we don't have directly like this. That is the reason why we have to mention list of like this. Okay, in Java, if at all, if you want to do little complex this one, but we can still define like this. Okay, Java RDD string. Just before that variable, we need to mention the data type of that one, right? That is what we are trying to mention here. And sc dot parallelize of erase dot as list fish, cat, stocks like this. Now, out of all these things, which one is easy for you? PySpark one only, right?
First one.
First one is easy one actually. We don't need to do all these things. Python is simplified our life, guys, actually. Okay. Commands are very simple. Understanding, we can even understand even hell lot of code uh, within hours, I can say. Okay. So second method I was telling you, right? Parallelizing method is one approach, and second method I was telling you, right? So this is what I was telling you. If you have text file actually in your local or in HDFS location or somewhere in the Cassandra or somewhere in the blob, then you have to read like this. Sc dot text file is one of the method actually. Lines are equal sc dot text file of this one. So each line it will try to consider as one one row as one element here, and it will try to divide the data based on that. Okay. So this is the command to create an RDD. In Scala, if at all, if you want to do same thing here, we just need to prefix here val. That's it. And if Java, if at all, if you want to do, you have to do like this. Okay, let me go back and check meanwhile. Hey, still it is executing now. Why is it so?
Even for me as well, Shiva, have tried to run the same. Yesterday we have run it. Yeah, for
Uh,
me to
but
it is
yesterday
open now.
it ran very quickly, right, for you?
Yes. Now it is worked. Even it was like taking time. Now it is worked.
Maybe I need to restart my system, guys, actually. Okay. I'll try to open that one tomorrow morning only, tomorrow class only. Okay. So meanwhile, we'll try to understand the core concepts here. Yeah. So this is the way actually to create an RDD. These are only two ways are there actually to create an RDD, guys. Only two ways, that's it. And one more time I'm repeating, you don't need to practice these commands. I'll tell you, I have actually these notebooks with me. Whatever the notebooks I opened, right? So I have these notebooks with me. Every command actually I've explained neatly here. Okay. And with an examples, I'll share these notebooks with you, and you need to run that one before the interview. Just run them and just try to understand the concept and go attend the interview. That's it. Okay, only for understanding the core concepts, not for practical use, I can say. You don't use these commands in real time because Databricks is not supporting RDDs. RDDs are gone almost. Okay. That is one thing. And one more thing is like, okay, see, ultimately, tell me one thing here. Um, Spark is related to something related to data engineering, right? Correct? Ultimately, what are we going to achieve with the Spark? What is our ultimate goal actually? If you have a data, if your application is generating terabytes
Processing
of
the
data, we have to process data, right? Process the data, right? We need to extract the data from the source and we need to give it to the Spark so that Spark process it. When you say process, what do you mean by that?
Transformation.
Transformations, exactly. Ultimately, our goal is to perform the transformations on top of the data and load that into
Another
respective
database. Yeah.
targets. Target can be anything. Target can be
Yeah.
table. Target can be file.
Yes.
Target can be um, like some other cloud. It can be anything. What your Spark will do is Spark cannot directly extract the data from these sources. Only few like it supports actually. Okay. Um, uh, Spark is majorly for the transformations. Majorly for the transformations. Okay. So now there are two things are there in Spark actually. Okay, there are two types of Spark operations are there. One is transformations and second one is actions. I'm going to discuss about these two in depth tomorrow with the practical scenarios. Okay, so in Spark, what are all the different transformations are there, actions are there? I have the list here. This is the list actually. In Spark, these are all the transformations, these are all the actions. Only these things, that's it. Only these things. If you understand about this one, these commands, these transformations, then you're done with the RDDs. Mostly I'll try to cover all these RDDs. Mostly I try to cover all these actions as well. Mostly, not 100%, but mostly I try to cover. Because nowadays we are not using that one, right? But just for understanding purpose, I'll discuss all this. Okay, and we do have pair RDDs as well. That means if at all if you want to perform RDD operations on top of key value pairs, then we call it as a pair RDD. So in the pair RDDs, we have only these transformations and we have only these actions.
But as you said, we won't use this at all in the real time.
Real time,
As
correct.
knowledge purpose.
Just for understanding, knowledge purpose, core concepts, understanding purpose, we need to understand all these things. Okay, because like once you understand the concepts in RDD, the same concept is there in the data frames as well. Ultimately, when you write something in data frames, backend it is going to convert actually RDDs only. Backend operations are RDDs only. Okay. Yeah, so I think I'm done. Let me go back and check here whether it does. Yeah, still it is executing. I don't know. I have to restart my system. But you can restart your system like after this class so that you'll get it very quickly. Okay. So tomorrow before your class, I'll just restart the system and I'll show you like how it is creating a Spark session in the backend. Okay. Yeah. So that's all from my end. Any questions so far?
Shiva, as you said, executors manage. We did not talk to executors, right? Who will manage
We don't interact directly with the worker nodes. We
worker?
always interact with the master node or driver node.
Who will manage those slave nodes?
No, ultimately, all these systems are connected in the same network actually. But only one system they'll expose to us. Only we'll interact only with this one. That's it. This master node will go and interact actually all these executors or worker nodes.
The cluster manager, Shiva,
Yeah,
all
yeah,
has
correct.
that
Cluster
information.
cluster manager sometimes it is installed in the master node only. Cluster manager is just a software as an application which we generally, which admins install that in master node. It's a program actually, I can say. It's an algorithm, I can say.
Okay, back-end process.
Process.
Exec-
Exactly.
Executors and tasks are back-end process.
Correct. Correct. Only your master node will go and interact with the executors. Okay. Clear?
Yes, Shiva.
Yeah. If no questions, let me stop recording.